Good morning. My name is Adezuka Yahaya, matric number GS63104. My supervisor is Dr. Josephine Liu Yingchuan. My seminar proposal is on the topic electrical and optical characterization of copper zinc tin selenide quaternary meta-chalcognite tin films via thermal evaporation techniques for photovoltaic application. The outline of the presentation: introduction, objective of study, literature review, methodology, expected results, conclusion, and references. The introduction: CTCZ is a quaternary chalcognite P-type semiconductor material suitable for photovoltaic application in solar cell, optical fiber, energy storage, up to electronic devices. It has also energy bandgap with an approximation optimal values of 1.5 electrovolt. The constituent element of CZTC are ethylene abundant chip and non-toxic with a content of zinc tin at about 79 ppm and 2.2 ppm in the crust. The compound has a high absorption coefficient of 10⁵ per centimeter, and this makes it suitable for mass production as solar absorber material. It has good electrical conductivity. Objectives of study. One of the objectives of study is to synthesize CZTC nanoparticles using servothermal method and to prepare CZT tin films using thermal evaporation techniques, and also to characterize the structural, optical, and electrical properties of CZTC tin film, and finally to test the efficiency of CZT tin film for photovoltaic application. Literature review. I have some literatures, some authors work on different materials and different methods to synthesize and deposit CZTC materials, and they came out with different findings, and they're all improved. As you can see, I have all of them. I have Liu 2016, Poganin et al. 2017, Henry J, Moharaj K, and Sivakuma G 2018 and 2021 LF. They all worked on different material and different methods, and the findings were all improved. As you can see, then literature review. Problem statement. Various techniques such as spotting, electrode deposition, pulse, laser deposition, spray pyrolysis have all been used to prepare CTC tin films, but the findings are still lacking visible efficiency. Conversion rate of 32.2% expected for CTC tin film for photovoltaic application. That's shocking quasi-theory. Then in this research, therefore, the thermal evaporation method is going to be used to prepare the CTC tin film due to its purity, which may yield higher efficiency for possible photovoltaic application. Method. As you can see, we're going to have between 4 tins with the method that's to synthesize, preparing CTC, characterize the CTC, and also to find out the application for any possible photovoltaic application. So then these are the materials and methods continue. These are the materials for synthesizing the CTC nanoparticles. You can see all the materials are analytical grade, like chloride, hydrate, dehydrate, acetic dehydrate, chloride, pentahydrate, aderic, selenium powder. They're all analytical grade, and these are the procedure. These procedures were done for 2 hours. Will be done for 2 hours, and what is expected is to produce a powder, a CTC powder that can be used for further studies. Then methods continue. You can see the preparation of CTC tin film by thermal evaporation. So this time around, we'll be doing the deposition using the thermal evaporation proper. So the materials that will be needed is CTC powder, XRO diffractometer, ball milling, and the rest of them. Then procedures. So these are the procedures. And at the end of the day, it's expected to have a higher efficiency of CTCZ film that can be used for photovoltaic solar cells. So of course, this is the thermal evaporation machine that we use for the deposition. Expected the result. It is expected that at the end of the research, at the end of this research, a pure sample or a pure formation of CTCT will be formed using XROD as characterization machine. So and it's expected that the CZTC pure formation will have no secondary phases. That's unwanted secondary phases. Then you can see this crystallized size for 3.5, then lattice strain 0.49, 0.419, lattice parameter ABC are respectively 5.6880, 5.6880, then 11.3380. So, then conclusion, so it's expected that when thermal evaporation method is used in this, thermal evaporation is used in this to deposit this CTC sample, a pure phase of CTC will be formed without unwanted secondary phases, and it's expected that the finding from this will make the CTC material yield higher efficiency for photovoltaic application. References, these are the references. There are some of already on the literature review, so reference continue. Thank you for listening. God bless.